In our previous lesson, we talked about solving equations that look maybe something like this, just over on the side here, all right. X plus 5 squared is equal to, say, 20. Okay, and when that happened, we understood that as long as we had the thing that's being squared by itself on one side, we could use the square root property, which says that the thing that's being squared is equal to plus or minus the square root of the right side. And we were also able to get x by itself. And of course, something like 20 could be reduced in the following way. So just very quickly here, reminding us of what we did in an earlier lesson using the square root property. But what that required of us is to have a quantity squared isolated by itself. And within that quantity is our variable, and there's not other variables outside of the thing that's being squared. So in this example, x squared we have, but there's another x over here. So this does not have the same format as this one. Now, the other thing you might try, though, is based upon some work we did before with solving by factoring, you might also try to take that equation and set one side equal to 0 and factor. But you quickly realize that this one does not factor, right? So we can't do this because it doesn't factor. So what do we do? Well, the answer to that question is if we can make this look like this one over here, then maybe there's still a way that we can use the square root property, right? So here's the idea. If I take x squared plus 8x, then is there something that I could add to this left side so that in the end, and I'll kind of put this further down, it breaks into x plus something squared on the left side, right? Is there a number I could put here so that when it factors, I guess in other words, it factors into two identical things, x plus something, where these somethings are the same? Because if it did, then it would turn into x plus that thing squared. Okay. All right. Well, if we can figure that out, the first thing we should note is if we do add something to this left side, that's only fair if we also add the same exact thing to the right side. Okay, so what do we add? Well, let's think about the fact that because of FOIL, the inside and the outside would have to add together to make 8x. Okay, well, how are the outside and the inside going to add together to make 8x? Well, the only way that that would work is if there's a 4 here and here, right? Because then I'd have 4x plus 4x gives me 8x. Okay. Well, if you put 4s in both of these spots, then that would have to mean that 16 would go right here, right? Because 4 times 4, the last times last makes 16. And if I add 16 on the left, I've got to add 16 on the right. So what that tells me is, yes, we can do this, and then it can factor into x plus 4 times x plus 4, and then that'll equal 17 on the right side, which of course becomes x plus 4 equals 17, or squared equals 17. And at this point, I can go ahead and apply the square root property. And then I can subtract 4 from both sides. So x is equal to negative 4 plus or minus the square root of 17. So what we just did is called completing the square, right? So X squared plus 8x, that's not a complete square that I can factor into something that looks like this. But if I add the right number to both the left and right side of the equation, then I should be able to factor it in this way and then use the square root property. All right, so let's look at what we did. First of all, when we were thinking about this 4, that came from the fact that 4x plus 4x equals 8x. And so since you want this number to be the same in both spots, that means that that number is going to have to be exactly half of whatever the middle term is. So half of, remember using the idea of b is the number in front of the x, so half of b. And then where did the 16 come from? Well, it just came from squaring that. So down here's our procedure. We get our equation in this form. Then we add half of b squared to both sides. So that's the 16 part. Circle that in purple. So the adding of 16 to both sides is half of the middle coefficient squared. Then you go ahead and factor like we did into a perfect square, and then take the square root of both sides. Don't forget plus or minus. That's using the square root property. And the nice thing about completing the square is it will solve any quadratic equation. Okay. So this business of some quadratic expressions factor and some don't, that's not a problem. Now that we have completing the square as a tool in our tool belt, it'll solve any quadratic equation. All right, let's do an example here. So x squared plus 6x minus 3. So remember the first step is you want to get any constant terms on the other side. And then what I always like to do is, as I showed on the previous page, I like to anticipate that I'm going to add something to both sides, and I like to put a plus, a blank on each side so I remember to, whatever I do on the left, I'm going to have to also do on the right. All right. Now, if I want to approach this kind of more formulaically, right? So here it says add b over 2 squared to both sides. So it's perfectly fine rather than kind of thinking about how do I want this to factor. It's perfectly fine to do this. 6 divided by 2 squared, right? As long as you're remembering, I take that middle coefficient, I chop it in half and I square it, then that's going to be the thing that you add to both sides. So we end up with x squared plus 6x plus, well, 6 divided by 2 is 3, and squaring that gives me 9. So the left side here, we know is going to factor into x plus 3, x plus 3. If you forgot the formula approach, you forgot, wait, what do I add to both sides again? Then remember what you would do is you'd think about how you want it to factor, and you would say outside plus inside must equal 6x. Ah, that must mean I put 3 in both of these spots, and then 3 times 3 is 9. So that'd be the way to kind of reverse engineer what the appropriate thing to add to both sides is. X plus 3 times x plus 3 is x plus 3 squared. And then apply the square root property. And in this case, we can do a little bit of simplifying here. There's a perfect square of 4 inside the radical. So this will be x is equal to negative 3 plus or minus 2 root 3. Here's another example. Go ahead and press pause. Try this one yourself. And then press play and see if we get to the same thing. All right, so I'm going to start by adding 3 to both sides. So plus blank equals 3 plus blank. And I know that I'm going to take that middle term, which is -4, by the way, chop it in half and square it. Now, if you did forget the negative, it wouldn't be the end of the world because of the fact that you square a negative and it turns positive anyway. And this would be -2 squared, which would be 4. So here, notice because it's a negative middle term, when it does factor, it's going to have to be x minus 2 times x minus 2. So x minus 2 squared equals 7. Square root property. We'll add 2 to both sides. All right. Now, the only other wrinkle we're going to throw into this is that, you know what? Sometimes we're going to end up with odd numbers as the middle coefficient, as the coefficient with the variable to the first power. So nothing really changes other than the fact that we have to deal with some annoying fractions, I guess. So y squared minus 5y, again, I'm going to add something. That'll equal -2 plus something. But at this point, we know we're always just going to chop the middle term in half and square it. Now, at first, it might make, the left side look a little bit more intimidating. So, when I do this, 5 times 5 is 25, 2 times 2 is 4. But the fact remains on the left side here, we know what this is going to factor into, right? We know it because we know that we need to put the same thing in both blank spots, and that same thing needs to add to itself to make -5. Well, what do you add to itself to make -5? Well, -5/2. That plus that will equal -5. But at the same time, when you multiply the last times the last, you get 25/4. So over here, though, we probably want to do a little bit of common denominator work to clean up the right side. So we'll multiply by 4 on top and bottom. So -8/4 plus 25/4. So this is going to be y minus 5/2 squared is equal to 17/4. All right. Now we can apply the square root property. So plus or minus the square root of 17/4. And before I get that y by itself, let's do a little simplifying. I know that I can break this square root symbol into the 17 and the 4 separately. So I can go ahead and take the square root of the denominator. So it'll be plus or minus the square root of 17/2. So when I go ahead and I add 5/2 to both sides, it'll be y is equal to 5/2 plus or minus the square root of 17/2. Writing it that way is just fine. At the same time, they both already have a denominator of 2, so it would be okay at this point to just say 5 plus or minus the square root of 17/2. Now, in this video, I've been a little bit more lazy and haven't broken up the answers always. I've left them as plus or minus, but I think this is just a good idea for a second to just pause here and let's remember that what we found are two distinct solutions, right? On the one hand, it's 5, 5 plus the square root of 17/2, and then 5 minus the square root of 17/2. This is showing me two distinct solutions. All right, go ahead and try this one, and then unpause it and come back and see how you did on it. All right, so here's one where we actually need to move an x back over here to the left side in order to get it in the form we want. So we'll add something to both sides here. And that something is going to be half of that middle coefficient squared. So we get x squared minus 9x plus 81 fourths. On the left side, the only way that that factors into something times itself is if it's x minus 9 halves in both factors. And we have a common denominator of 4. So this gives me negative 4 over 4 plus 81 over 4. So x minus 9 halves squared is 77 fourths. So when I apply the square root property, x minus 9 halves is equal to plus or minus the square root of 77 over 2. So x is 9 halves plus or minus the square root of 77 over 2. So that should be a 7, not a 1. And then again, not a bad idea just to write them separately to emphasize that we have two distinct solutions to this problem.